Let's open the document first, okay? We started with Maven, so we want to continue with the Maven. Okay. So to to develop the first Spring application and to develop all the rest of the Spring applications. At the same time, also to develop the Spring Boot applications and also to develop the microservice applications. So basically, if you want to develop, okay, Spring Boot, microservices, all these applications, if at all you want to develop, you have to use one of the build tool. That build tool could be either Maven or Gradle. Okay, right. So initially we started our discussion with what is called build process and what are the steps involved in the build process. And to automate the build process, we need one tool, and that is actually called as Maven. So today we are going to understand about Maven related things. Maven and Gradle are the build tools of Java projects. Okay, so these tools are used to automate the build process of an application. Whatever the steps I have given here, yesterday I have explained about them. All these steps will be taken care by the build tool called Maven. So as a developer, I will write the code, and after writing the code, there is a tool that is supporting me, and that tool is called Maven. And this Maven will automatically will take care of compiling my source code by downloading the jars and adding them to the class path. It automatically execute my test cases by downloading and adding them to the class path. And finally, it is going to package my application into a jar file or a var file and gives to me. Once that jar file or var file is created by Maven, I am simply going to deploy this var file or jar file into the server for the either testing or for production or for pre-production, whatever it is. So these are all the steps which are automatically taken care by the build tool. That is called Maven. So it is going to automate the build process of the project. This is yesterday's session that what we discussed. There are build tools available who can do these things automatically for me. One is called Maven and second one is called Gradle. And both are the tools which are given by Apache. They are provided by Apache. So we are going to learn Maven. Good. Now, to start our discussion with Maven, at the time of creating all the Java applications, whether it could be the application that we are developing with a Spring framework, or we are developing an application for Spring Boot with a Spring Boot or microservices architecture, whatever it is. All these Java projects are called as now Maven projects. Okay, all these Java applications are all these projects, we are going to call them as Maven projects. If I'm using Gradle as a build tool, so then I'm going to create a Gradle project. So my Java project is now going to become like a Maven project. So every day we are going to create a Maven project. Every day we are going to create a Maven project, or we are going to create a Gradle project, because we are going to use this build tool in order to automate the build process of my application. So we are going to call it as Maven project or Gradle project. Like that, we are going to call the terminology. Okay. Now, while creating or while developing the applications using the Maven as a build tool or Gradle as a build tool, first we should understand about how does the project structure looks like, right? Maven can do all the steps what I told in the last class, 1 to 7, from step 1 to step 7, and not only this 1 to 7, more than this. Actually, Maven has lot of features. Many features are there in Maven tool. I mean, Maven is a tool which provides not only build process, more than the build process. Okay, right? We are using it for automating the build process of our application. But actually, Maven can do more than that. Okay, Maven can do more than build process. It has more additional features also. Okay, done. So, who will automatically do this 1 to 7 steps now, which is automatically done by the Maven tool. So, means we are going to create a Maven project to develop our Java application, or Gradle project to develop a Java application. Okay, when you are creating a, for example, Spring Boot application, we are going to develop next. Or first, initially, we are going to start the Spring framework. So when you're getting an application, a first application using Spring or application using annotations, what type of project we are going to select? Maven project. Every Spring Boot application also called as Maven project. Okay, right? So means finally we are going to call them our projects are what projects? Maven projects we are going to develop from now onwards. So for that you should know about the project directory structure, because Maven will follow a concept called as naming convention over configuration principle. What Maven says, you no need to write more configurations for me. I will take care of build process, but you follow the naming conventions. So we are going to understand about, now we are going to understand about what is the structure, project structure, which is called Maven project structure. Now our Java projects are going to be called as Maven projects. If I'm using Gradle tool, then my Java project is going to be called as Gradle project. Okay, right? Good. This is just only to show you. I'm not talking about more on this. Leave about that. As you can see here, project. Actually, this, okay, this Spring Initializer is another tool. This tool we use actually to develop the Spring Boot projects. But currently we are not talking about the Spring Boot. Just we are creating with the Spring applications only. Just why I have opened this page is just to show you the project type. Okay, Maven or Gradle, right? So if I choose Maven, then my project is going to be called as Maven project. If I choose Gradle, then it is going to become like a Gradle project. Are you able to get my point now? Maven or Gradle, anyone I can use. Maven or Gradle. So first we are going to start with what? Maven. Just I've opened it to show you. You see, under project category, we have Maven, Gradle. Under language category, Java, Kotlin, Groovy. Spring Boot applications we can develop using language Java or another language called Kotlin, which looks like Java only. And one more thing is Kotlin application also runs on JVM only. Kotlin application, Kotlin code also runs in JVM only. JVM supports Kotlin also, not only Java. Okay, Groovy is another scripting. So there are Maven projects and Gradle projects. So from now onwards, what is the terminology? We are going to call our Java project as a Maven project. Okay, right. Now we should understand about the project structure. Now we need to understand about Maven project structure. We want to understand about Maven project structure. Okay, see, we are going to understand about something called as Maven project structure today. Let's start. We know every project has name. Means what? Every project has a project folder. Project name, your choice. Whatever the project name that you want, you can keep it. But inside the project folder, there is a folder created called SRC. SRC indicates what? Source. Okay, source folder will be there, SRC folder. Again, under SRC folder, whenever we create a Maven project, under the project folder, whatever the name that you want, you give for your project here. This is the folder of your project. One project is one directory. Under this project folder, you can see a child folder called what? SRC, subfolder we can call. Subfolder is SRC. Under SRC, you can find out another subfolder called main. Under main, you can find out one more subfolder called Java. Okay, right. Understand here. Under SRC, you can see one subfolder called main. Under main, you can find one more subfolder called what? Java. So we call source SRC main Java. The location is like this. src/main/java. Similarly, under main only, you can also find one more subfolder, and that is called as resources. We call it as source/main/resources. Again, under SRC folder only, we are also going to see one more subfolder called test. Again, under test, you can see the subfolder called Java. Now we refer it as source/test/Java. Again, under test, there is one more subfolder is going to be available here, that is called as resources. This we should create explicitly. Mostly we don't create that, but okay. Source, test, resources. Okay. So now, whenever you are creating any Maven project, the project contains a folder called source, SRC. Under SRC, there are two main subfolders are there. Who are they? Main and test. Again, under main, there are two subfolders called Java and resources. Under test also, there are two subfolders called Java and resources. So how do we refer this Java folder? Source main Java. How to refer this resources? Source main resources. Like this, there is a structure that Maven project is going to contain. And under this Java folder means source main Java at this location, we are going to keep our Java source code files. Our Java source code files are under source main Java. Source code files means all your classes, whatever you want to develop, maybe in a one package or maybe in different packages, all your packages, under that packages, whatever the classes you want to create, all these things are going to come under source main Java. So this is the place, source main Java is a place where we need to store our source code. Next, apart from source code, right, apart from source code, if any additional resources are required, means like XML files or YAML files, YAML files, or properties files, these are called additional resources of the application. XML files, YAML files, properties files. Sometimes we also create SQL files, .SQL extension. All you are going to see in further applications. So these are all called as additional resources of the project, right? So these additional resources we need to store at a location called source/main/Java. slash resources. src slash main what slash resources. So here we are going to store what files? XML files, YAML files, or properties files, SQL files, etc. These are all we are going to store in src slash main slash resources. At this place, you need to store them. And if you are writing any test cases, all the test case files you need to store in src slash test slash java. Here you have test cases. These test cases we are going to write with the help of a tool called JUnit. JUnit and Mockito we are going to use to write the test cases. So this is the place where you can keep the test cases. And to compile and run the test cases, if any resources are required, those resources we are going to keep in src slash test slash resources. Could be flat normal notepad files or XML files or YAML files, properties files, any files. So whatever the files required, but these files are to run the test cases. Okay, to run the test cases, if any additional resources are required, those additional resources we are going to store them in location called what? src slash test slash resources. So we need to understand first of all these are 4 locations in Maven projects. First location is what? Source slash main slash Java, src main Java, src main Java, src main resources. Similarly, src test Java, src test resources. So where do you keep your all project, whatever the development files or whatever the Java programs you are writing for your project? Suppose I am writing some controller class, some service classes, some data access layer classes, all the classes I am developing. Where I am going to keep all my source code files? src main Java. You remember main Java, main resources. src common. Next one is what? Test Java, test resources. Main Java for source code. Main resources for other files of our source code. Suppose I want to develop a Spring application. As I said, initially we are going to use Spring configuration XML file. So where I am going to store that XML file? Where should I store that XML file? Under resources. Where should I store my dependent class, my dependency class, my independent classes of the project? src main Java. Main Java is for source code. Main resources for other files, other resources, additional resources, right? Similarly, if I'm writing test cases, where should I keep my all test cases developed? I should store them in test Java. And to run the test cases, if any resources are required, so where should I keep those resources? Test resources. Very good. So every Maven project is going to contain this kind of project structure. src main Java, src test Java, src main resources, src test resources. And this project is going to contain under the project folder, there is an important file will be created that is called form.xml file. What file created? Form. Every Maven project definitely contains what file? Form.xml file. Form stands for project object model. Form stands for project object model. Okay, right. So basically every Maven project is going to contain a directory structure like this. Now there is a project you are creating. You can give any name for your project, and under the project folder, Maven project structure contains like this. Now under the project folder, what folder is created? src folder created. Under src, main is a one subfolder and also test is another subfolder. Under again main, there are 2 subfolders created called Java and resources. Under test also 2 subfolders are created called Java and resources. Very okay. Try to understand now. If any folder is not created, we have to create them manually. We have to create them manually if not created. For example, src main Java, src test Java are definitely created. Mostly src main resource also created. If not, then we have to create manually the resources folder. If at all you want to store the files like XML files or properties files or SQL files or YAML files or whatever it is. Okay, and the most important file of the project is called what file? Form.xml. By observing this XML only, this project is identified as a Maven project. The project object model, POM, stands for project object model. I'll tell you what is the purpose of this XML. This is the important XML file. Which is important XML file? Form.xml. In this XML file, mainly this XML file we are going to use. Mainly this XML file we are going to use to configure the or to add the dependencies. Mainly we are going to add or we are going to use this XML file to configure the dependencies of our project. Dependencies means here the jar files required for the project to compile and execute. We are only going to write the dependency, but who will take care of downloading the dependency? Maven only. I told build process steps. Downloading the dependencies means jar files, adding them to the class path, compiling, downloading the test related jar files, adding them to the class path, compiling and executing the test cases, then packaging the complete application into one single file like a var file or a jar file. Who will take care of all these 1 to 7 steps? Maven will take care. But in this form.xml file, what should I do as a developer? I should tell the Maven that these are the jar files required. We are not downloading, we are only telling. That is called, we are going to configure dependencies. This form.xml file is to configure the dependencies of our project. Here dependencies means what? Jars. Dependencies means what? Jars. For example, I am creating a Spring project. Then tell me to develop the Spring application. I told yesterday approximately to compile and execute the first Spring application. How many jar files required? At least 6 jar files required. Just for the first application to compile and execute a first Spring application, at least how many jar files required? 6 jar files required. But I am not going to download them. I am not going to download them. I am not going to set in the class path. Nothing is done by me. Okay, I will tell the Maven that these are the jars required. Where should I write that information? In the file called form.xml file. Project object model form.xml file. In this XML file, I will configure what? Dependencies. Here dependencies means what here? Jars. Jars. If I configure them, then who will download them? Maven. Who will download them? Maven. Who will add them to the class path? Maven. Then who will compile my code after that? Maven. 1 to 7, all the steps will be taken care by Maven. So what? Mainly in the form.xml file, what we are going to configure? Dependencies. I'll tell you how to configure the dependencies. Here dependency means what? Jar file. Jar file. Okay, right. If I just configure the dependency, who will download the dependency? Maven. So which is the most important file in the Maven project structure? Right. By this file only, this project is identified as a what project? Maven project. If in case by mistake or wantedly, whatever it is, you have deleted this file. Which file you have deleted? Form.xml file you have deleted. If you delete this file by mistake or wantedly, we don't know, but it happened like that. Suppose if this file is deleted, then tell me this project is going to execute like a Maven project or not? No. Maven does not do all these tasks. What task? It does not download or it does not add the jars to class path. It does not going to compile the code or nothing. It is simply going to give you errors. So which means what is the most important file of the Maven projects? Form.xml. Very good. Again, come to the point. Again, come to the point. I will explain. Try to understand now. Of course, I'm going to give you all these things. Suppose now I'm going to use Eclipse or STS. I'm going to use STS tool. Okay, STS tool means STS is also like Eclipse only. Okay. STS stands for Spring Tool Suite. We are going to use STS IDE better. Instead of tool, I'm writing IDE. Every IDE is a tool, but IDE is a word that you know already. STS is the IDE that we are going to use. STS IDE we are going to use. Are you able to get my point? Right. Because STS looks like Eclipse. STS looks like Eclipse. Okay. Next we use IntelliJ. So most of the applications I will teach on IntelliJ because Eclipse you already people know. Most of the applications I'm going to tell you on IntelliJ IDE. Okay. But initially, just to write first 2, 3, 4 applications, I'm going to use STS. Okay, right? Both are important for Spring application development, either Spring Boot or microservices, whatever it is. Now, what is the tool that we are going to use? STS first. STS stands for Spring Tool Suite. It is like Eclipse only. STS like Eclipse only, but STS contains Spring features included. So it's easy for application development for Spring, for Spring Boot and all. For Spring Boot and microservices, Spring Cloud microservices, to develop this kind of applications, this IDE has built-in features. Actually, this is developed on top of Eclipse only. We are going to use this. Whenever we are using the STS IDE, for example, we are using which IDE? STS IDE, we are using it. Good. We are using STS IDE. Now, what happens when you are working with STS IDE? Understand here. Project folder is created. Whenever I'm creating a Maven project with STS IDE, I can directly use Eclipse also. But instead of Eclipse, I'm just going to use which IDE? STS, because STS also looks like Eclipse. Actually, I can say like this now. STS is developed on top of Eclipse. It is Eclipse plus Spring features. Okay, Eclipse is an open source IDE. Any company can use Eclipse as a base and they can create their own IDE on top of it. So STS is also created on top of which IDE only? Eclipse IDE. In STS, Eclipse, it looks like Eclipse because it's built on top of Eclipse only. Plus, what are the additional things added? Spring features are added to develop the Spring Boot and microservices applications. And finally, they have given another name called what? STS. Spring Tool Suite. So whenever you create a project in the IDE like STS, or even in Eclipse also, no problem, you are getting project folder. Under project, you can see the folder called SRC, and remaining all will come here. SRC contains what? Just now I told you, Maven project structure contains folders called source. Under source, there is main. Under main, there is a folder called what? Java. Okay, right? And remaining all there. Main, under main, one more folder will be created. That is called what? Resources. Okay, resources. These are all created. Again, under main, under SRC, test folder also created. Test also contains folders called what? Main, Java. Next one, resources. So everything will be there. And pom.xml file is also there. But at the same time, you are also going to get a shortcut to reach it easily. I no need to open SRC folder, then main folder, under the Java folder. I can easily get here SRC / main / Java. The ID will give a quick link to go to there. Which means first I want to tell you that this location, both are not different, both are same. Now you tell me, if I want to write one class, one dependent class or a dependency class, some class I want to write. I no need to open SRC folder, then main folder, then Java, then right click. I know do all these things. Already a shortcut is there here. What's the shortcut? Source slash src slash main Java. Here I can right click, I can write the Java file. So which means this src main Java and this shortcut src main Java both are one and same. Don't feel that they are two different things. First, this must be very clear. Similarly, you can find here. What you can find? src test Java. Or you can also find here src slash main resources. In the Maven projects, you are going to get the shortcuts like this whenever you are working with the IDEs. Okay, correct? These locations are same. You can right click here and you can write the Java file. Otherwise, open src folder first, expand it, then go to what? Main, again expand that folder. Then you can see what? Java. Here you can right click and write the file. Both are same, but this is quickly, easy way to go there. So these are what now? These are the shortcut locations. They are the shortcuts to reach these locations. Okay, whenever you are creating the project in your IDE like STS or Eclipse, you will also see the locations like this. These are the quick links to navigate to this location. But you don't feel that these are different files or different folders and these are the different folders. Both are one and same. They are not different. They are one and same. Okay, right? Good. First, let us draw the project structure. Project structure is only first important. And what is the most important file in the Maven project structure? Pom.xml. Mainly that XML file is for what purpose we use? We are going to add the dependencies required for the project. Dependencies required for the project is called nothing but what? Jars required for the project. Jars required for the project. If I specify the jar files, who will automatically download them? Maven. And who will automatically take care of adding them in the class path? Maven. Then who will compile my source code? Maven. So everything will be taken care by Maven. All the build process steps will be taken care by Maven. So we should understand how does the project structure looks like. So I want to draw the project structure here. Then I will copy paste it. You are learning something about Maven because this knowledge is important to develop the Spring applications. Right from first application onwards, we are going to write our applications using which tool only? Maven tool only. Okay. Done. Observe here. First, what I'm trying to say that we want to create a project. So we want to create a project, which is a Maven project. Okay, done. We are creating a project. I told just now. So we are creating a project, Maven project we are creating. So this is a project I want to create now. Project. Now tell me, in this project, okay, I'm talking about what are the folders available in this project. Whenever we are creating a Maven project, what are the folders created? What are the folders created? So tell me, under the project I told just now, which folder is created? SRC folder is created. Let us, because we need big directory section. Okay, no problem. There is a folder, there is a folder created called, what the folder name? SRC folder created. SRC folder created. Okay, good. Tell me, under SRC, what are the subfolders created? Main, test. First, we want to write main. Tell me. First, we want write main. Oh, correct. Main. Understand clearly. Now you tell me under main again whether there is a subfolder created. What is the subfolder created under main? Yes, under main there is a subfolder created called what? Java. Another subfolder created. What's the name of that? Resources. Resources. So first I want to write under main. You can able to see one subfolder. That subfolder name is called what? Java. My next question. Tell me under the Java folder. Under this what folder? Java folder. My question is what we are going to save in the Java folder? Source code. Source code means .java files only. Source code means what files only? .java files only we are going to store here. Java files we are going to write. I'm simply going to say that star.java in brackets I'm writing source code. Source code. Good. Now you tell me under this src main only after Java, what is the other folder created? Resources. Resources. Okay, once we start, you are going to see how it is going to look like. Now tell me, what folder is created? Resources. Just a minute. It's good. Resources. One folder is created resources now. Tell me under resources folder, what we are going to store? Other files required. What kind of files we are going to write in the resources? Okay, mostly XML files, properties files, YAML files. In the projects you are going to learn later. Okay, right? Star.xml. Okay. Star.yml. Star.sql. Okay. Star.properties. Okay, just I'm writing comma without increasing my diagram, etc. So tell me these kind of files we are going to store under which folder? Resources folder. The additional resources required for the source code, maybe the configuration files or YAML files or properties files or SQL files, all these files I'm going to store in a folder called what? Resources. Resources folder. Very good. Next. Observe it. Now this is SRC. Under SRC there is main. Now come to the point. Tell me now. Okay, tell me now. Under SRC, under SRC there is one more folder also created. What is the other folder name created? Test. Test folder is created. So there is a folder created called test. Okay, test folder is created under SRC. Again, test also contains a folder called what? Java. Test also contains a folder called what? Java, and also contains a folder called what? Resources. Okay, so I will do one thing. I'll simply copy. I can do that. Just a minute. Instead of writing them, I can. Okay, so I'm done. Good. Tell me, this is source code or test cases? Test cases. Test cases also Java files only. Test cases are also what files only? Java files only. And to develop the test cases, we are going to use a tool called JUnit. What's the tool name? JUnit. Tell me, this is called source code or test cases? Test cases. We are going to write this unit test cases, and they are also called Java files only. Okay. And also whatever the resources required, those resources we are going to keep under resources folder. These resources are for source code resources or test cases resources. Test cases. If any resources are required to compile and run the test cases, those resources we are going to keep under resources folder here. Okay, right? These are only for compiling and executing the test cases, but not for source code. So at both places you can see resources folder. Okay, right. Now, what is the most important file of this project? Form.xml. The project is going, this is the basic structure of the Maven project that we need to understand. I will show you like how we can able to create the Maven project. Okay. Let's say, okay, I'm done. So first I want to copy this. I want to export this into our application, sorry, into our document so that you people can able to have this into your document. I'll show you that. So we got the project structure. Very good. Okay. So in this, what is the most important file? Form.xml. Form stands for project object model. Okay. I told already, whenever we are creating a project in our IDEs, we are also going to get some IDE also will provide us some quick navigation links to reach the resources, to reach the Java folder and all. So I'm going to show you that. First of all, let us open the official website of the Spring Framework. What is official website of the Spring Framework? Spring.io. Okay. Now, in the Spring.io, if you just go to projects menu, under the projects menu, at the end, you are going to see something called as development tools. And under the development tools, you can able to see something called as Spring tools. Click on the Spring tools. Okay. Understand, Spring tools is the next generation of Spring tooling for your favorite coding environment. Okay, right? Understand? Spring tools for Visual Studio Code. Spring tools for Eclipse. So currently we are going to use Spring tools for Eclipse. So here you are going to download whatever the version, I mean, based on your OS. Okay, you are going to download and you are going to install it. Once you download and install, let's say for Eclipse, then you are going to get a shortcut like this. Okay, Spring tool suite. Spring tool suite means version 4, of course. 4 dot something is called 4 only. Then tell me Spring tool suite in shortcut, it is called what? STS. STS. It looks like what? Eclipse only. It looks like Eclipse only. It's going to ask workspace. Like in Eclipse, whenever you are developing an application, you have to choose your workspace or not. Yes. Okay. I'm taking my workspace name is test, just to show you today. Launch. Very good. Just observe it. Here, I want to create a new project. File, new. But what kind of project I want to create now? Maven project. In STS, Maven project is there. Spring Starter project is there. Spring Starter project means Spring Boot project. What's the name? Spring Boot. But we are not developing Spring Boot project now. First, initially, we are going to start with what kind of projects only? Just Spring project, normal Spring framework. So I'm going to choose what type of project? Maven project. I'll click on next. I'll tell you all these things later about Maven archetypes. In Maven, some terminology, you should know many things. You should know many things. I'll tell you that. But first, I want to show you the project structure because I have not explained you what is group ID, artifact ID, and all those things. So why I'm creating now to show you how the Maven project structure looks like. Again, the steps and all I'm going to tell you. Don't worry. It is downloading. So whenever you are, when you want to create a Maven project, it is mandatory that your system must be connected with internet. Okay, done. Just observe it. Okay, I do not want to tell anything more, but first I want to tell you. Just I'm increasing the font size, guys. It is not a big thing I'm doing here. Just a minute. This is only for increasing the font size. It is not a step 2 to explain you. Okay, let's see with 14. Now you can see you got a big name here. Observe here now, demo. It is a Maven project. It is what kind of project now? Maven project. Maven project. Now, just now I told you. Actually, Maven project contains one important file called what file? Form.xml. Form stands for project object model. Project object model. That the purpose of that file is to configure or add the dependencies required for the application. So we'll understand dependencies means jar files required for the application. Okay, right. So there is a file called what file? Form.xml. There is a folder created called what folder? SRC, source. If I open source, under source, what and what folders are created? Main and test. Physically, I just want to show you so that you will get some confidence. But at the same time, here also you are finding SRC, main, SRC, test. I told these two are what? Just quick links. Quickly you can reach to this location and these are the shortcuts. This ID will provide you the shortcuts. Okay, right. If I open the main, what the folder you are going to see? Java, resources. If resources is not there, I need to create it. Are you able to follow me? Okay, good. So if I want to open this main, it is not allowing me to open this main. I need to change the view type. Show view. This is presently called Package Explorer view. What view? Package Explorer is a view. This is a project view in Package Explorer. So I want to change to Project Explorer. Now this is another view of the project. Project Explorer. SRC. In the Project Explorer view, I can see the subfolders. Main. Remaining means I'll explain. Don't worry. Main. Tell me under main what is there? Java. Test. Under test also, what is there? Java. Then tell me how to reach this Java as a shortcut. You have the link provided here. Are you able to follow me now? So both basically this source main Java, this SRC main Java, both are same. This SRC test Java, this SRC test Java, both are same. So don't feel that these two are different, these two are different. It is not like that. All are same. All are same. This is what I want to show. Oh, correct? Observe it. Under Java, by default one hello world program is created. I'll show you that. What is in dot Ashok IT? In dot Ashok IT dot demo is going to be the package. In under that Ashok IT, under the demo, these are the package name. This is the package name in. Sub package name Ashok IT. Under that sub package name demo. For the file created by default app.java. If you want, you can open it and you can see that. See, the package name is what? In dot Ashok IT dot demo. By default created. We are going to remove that later. So tell me one hello world class is by default created. Whenever you create the project, that's okay, leave it. It's created or not, that is not mandatory for us, but I just want to show you now. So tell me what is in Ashok IT demo? In dot Ashok IT dot demo is what name? Package name. In package name, in is the parent package. Sub package is what? Ashok IT. Under that sub package is what? Demo. And what is the file name? App.java. This is a source code, for example. The same thing I can also find from the shortcut location now. Yes. You tell me, this is source main Java. It's a shortcut to go to the Java under main, right? Very good. Tell me what's the package created inside that? In.ashokit.demo. In this package, what is the Java file created? App.java. So this view is very easy to go there. Otherwise, I need to open what folder? SRC. Then I should open main. Then I should open Java. Then I should open in. Then I should open Ashok IT. Then I should open demo. Then I can see app.java. Instead of opening these many folders, it's a quick way to go there. So that's what I'm trying to say. People will confuse why 2 times created. Just it is to navigate to the location easily. Okay, because we are going to keep our source code under source SRC main Java. SRC main Java. This is a place where we are going to keep our source code files. What is the important file of the project? Form.xml. It is one XML file. You can see the big XML file is available here. XML file. But in this XML file, what is our responsibility? We are going to add the dependencies. Dependencies means what we are going to add? Jar files. Where we are going to add them? Under a section called dependencies section. Which section? Dependencies. Are you able to see the dependencies section in this XML file? Yes. Under this dependencies section, we are going to write the dependencies. How do we write the dependencies? We are going to add a tag called dependency. We are going to add a tag called dependency. Of course, I'll tell you, dependency means what here? Jar. Dependency we are writing in XML file is called what here? Jar. This dependency tag is to configure the jar file required for the project. Who will download this jar file? Maven. Are you able to follow me now? I'll tell you from where it is downloading and all later. But are you first of all understanding there is an XML file available called, what's the file name? Form.xml file. Very good. Dependency means what here? In the form.xml, dependency is nothing but jar file. Jar file. Very good. Try to understand now. I have to explain you. Everybody, please try to understand. Dependency. I'll explain now only. Dependency. First, I want to talk from dependency onwards. Under dependency, I should write one tag called group ID. It's very important. It's very important to understand Spring, Spring Boot, microservices, everything. This dependency is very important. Okay, so tell me. Okay, so tell me under dependency tag, what is the child tag I'm writing? Group ID. Already one dependency came. that we by default came. Okay, by default came, but I am writing my dependency now. Group ID. I'll tell you. Just a minute. Okay, so observe it. Dependency. Everybody. Dependency. Under dependency, what's the child tag? Group ID. Another child tag, artifact ID. What is ID? Artifact ID. Okay. Next, the child tag version. These are the child tags required. What are all the child tags required? Group ID, artifact ID, version are the child tags required under one tag. Dependency. Where do you write this dependency tag? Under dependencies, this file is called what file? Form.xml. What is the purpose of writing the dependency tag? To configure the jars. To configure the jars. Okay. Now coming to group ID value. Actually, every every framework or every group, better word. Okay, there is a unique ID for a group. That is called group. Group ID is to uniquely identify a group of jars. Okay, you feel one jar, you feel like one small project. This project is created by one group. One group means one company. Okay, all the projects created by that company, by that group, will have an ID. They are identified with ID. That ID is called what ID? Group ID. Okay, understand clearly. One small jar, you feel like one project, one small project. One jar looks like one project. I mean, one small application, one project. That project is created by a company. That company creates multiple projects. So all those projects are identified with one group ID. So group ID is a unique ID of a group or a company who created jars. Jars means small projects, applications. For example, take Spring Framework. We know Spring Framework is going to support us so that we can able to develop our applications rapidly, fastly. Why people are using Spring Framework or Spring Boot and microservices to develop the applications? Because that framework will provide us almost 50 to 60% of common code. The common functionalities are provided by framework. Am I right or not? So how those common functionalities we are going to get to our application? How those common functionalities our project is going to get from the framework now? To get that common functionalities, we are going to add the jars. These jars contain that common functionalities. These jars contain that common functionalities. Are able to follow me now? Very good. So tell me now, if I want to develop a Spring application, then I need to add Spring jars. I need to add some Spring jars as dependencies. Who created and given these jars? Spring Framework. Spring Framework provided many jars for different features. For example, for security. For example, for database accessing. For example, for MVC. For example, for AOP. Different jars are provided. Which features you want? Add them. Add them as jars. For all these features, different what are given? Jars are provided. Who provided them? Framework, right? Out of that, I want this feature, that feature. Add those two dependencies. Nothing but what adds those two jars as dependencies. Okay, for all these jars, there is a one common group ID. So group ID is nothing but what? Group ID is nothing but a unique ID for a group of projects created by the company. Created by the company. For example, let's say Ashok IT is a company. Let's say Ashok IT is a company. Understand it clearly. Ashok IT is a company, and Ashok IT is creating 3 projects. Ashok IT is creating how many projects? 3 projects Ashok IT is creating. So what is the group ID of the 3 projects I want to keep? The Ashok IT company projects should be identified with a group ID called in.ashok IT. In.ashok IT. What is in.ashok IT? It is a group ID. It is a group ID of the projects developed by organization called Ashok IT. How many projects Ashok IT developed? 3 projects. Ashok IT developed 3 projects. 3 projects. Then tell me, these 3 projects are identified with a group ID called what? In.ashok IT. These 3 projects are identified with a group ID called what ID? In.ashok IT. Yes, in.ashok IT. Are you getting my point now? Right. For example, Infosys is creating 100 projects. Infosys is creating how many projects now? 100. They are creating 100 projects. So all these projects are developed by, are created by, are developed by the same organization. For example, the group ID for these projects Infosys has provided com.infi. Example. So what is com.infi? Is a group ID for the projects, 100 projects created by Infosys. Okay, what is in.ashok IT? Is a group ID for the 3 projects created by Ashok IT company. Like that, for every company, means for every organization will have a unique ID, which is called what ID? Group ID. A group ID for their projects. So tell me now, I am working with the Spring Framework. Assume that Spring Framework is one company, is a company or one organization, whatever it is. It's one organization or one company. Right? So tell me, Spring Framework has given many jars. The framework jars. You feel that those jars are called some projects. Let's say, for example, they have given 25 projects. How many? 25 projects. 25 projects means 25 jars, for example. 25 jars. Finally, project is going to be jar or var only. Okay, 25 projects. So tell me, for all these projects, to identify all these projects uniquely, the Spring Framework team, that company has given the group ID as org.spring framework. What is the group ID given? org.spring framework. What is org.spring framework? It's a group ID. It's a group ID to identify the 25 projects which are developed by Spring Framework, or which are given by or created by Spring Framework. So group ID means what? Group ID is nothing but the ID of the organization. What is that? ID of that organization could be a company or a framework or somebody else. Are you able to follow me now? Right. ID of the organization. That's called what ID? group ID. Next, child tag is what? Artifact ID. Artifact ID means name of the project. Name of the project. Here, name of the project is called name of the jar file. Na? Name of the jar file. Because in Java, one project is released as either a jar file or a var file. Either a jar file or var file only. Understand clearly. A project is released as a jar file or var file in Java. The only two ways, jar or var. Let's say jar here. Then tell me, artifact ID is nothing but what name? Artifact ID is nothing but what name? Project name. Project name is nothing but what here? Jar file name. What file name? Jar file name. Next what? Version. The version of the project. One project can have multiple versions. Initially, when project started, 1.0 version of the project is released. Okay, after 3 months, its version changed to 1.2 by adding new fields, new modules, new features. In the next, again, after 3 months, for example, version changed to 1.3. Am I right or not? Version. For example, you take Spring Framework. What is the current version of Spring Framework? 6.2.2. But Spring started from version 1.0. Am I right or not? Very good. So tell me what group ID represents? What group ID represents? A unique ID of the organization of the company. Artifact ID represents project name, which is called jar file name. Next one is what? Version. Let's say, for example, I'm writing like this. Just for example, I'm writing like this. org.spring framework. When I'm typing, automatically are getting some suggestion. Okay, org.what? Spring framework. Very good. Next, I'm writing artifact ID spring hyphen context. Next, I'm writing version, for example, 6.2.2. All the errors are gone. Are you able to follow me now? Then you tell me, just have written, I'll explain you more in later. Okay, slowly understand. Now, Maven is such a point that you are going to learn day by day more knowledge on that. Not in a 1 day more knowledge, day by day. Then tell me, group ID is nothing but what ID? ID of the organization. What is the ID of the Spring Framework organization? org dot. This ID is to identify the projects of the organization. So what is the ID given by Spring Framework people to identify the projects of Spring? org dot Spring Framework. Okay, next. Artifact ID means what name? Jar file name, which is also called as what name? Project name. Project name. This is the version. This is a version. This is called dependency. Where are you writing this dependency? In a file. Which file? pom.xml. So what is the purpose? What is the main purpose of writing the pom.xml file? What we should do in the pom.xml? We need to add the dependencies required for the project. We should add the dependencies required for the, or we should configure the project dependencies. We should configure the project dependencies in a file called what file? pom.xml file. So to configure the project dependencies, we are going to use one tag called what tag? Dependencies tag. This tag we must write under which section? Dependency section. And under dependency tag, what are the 3 important child tags? Group ID, artifact ID, and version. Group ID represents what? Group ID represents a unique ID of an organization, organization or a group, whatever it is. Okay, right. Second one, artifact ID represents name of the jar file, which is also called project name, Next one, version of the project. Are you able to follow me now? Now, within 2-3 minutes, you understood. But to explain this, I took half an hour, which is nothing but what Maven, you are going to learn like that only. Maven at a time, nobody can understand. At the very initial days of Maven, even it took a lot of time for me to understand what exactly happening in Maven. So it takes some time. Don't worry on that. Okay, good. Try to understand all these things. So this is one dependency I've written. Suppose I want one more, I need one more dependency. Then I should configure again one more dependency. For example, dependency, I'll copy paste here. For example only, I'm not talking about, actually not required, just for to tell you that like this, you can have multiple dependencies I'm writing. For example, I'm writing Spring hyphen core. Okay, leave about that. So basically, did you understood about what we are going to do in the pom.xml file? What we are going to in the pom.xml file? We are going to add the dependencies of the project. Dependencies nothing but the jars required for the project, for our application or for this project. For this project, whatever the jars required, those jar files are those jars we are going to configure. Okay, the libraries we call them, those libraries we are going to configure in the pom.xml file by using a tag called what tag? Dependency tag. Very good. Very good. So first, after this project structure, there is lot of things to discuss here. We will discuss. First of all, tell me pom.xml. Pom stands for what? Project Object Model. Project Object Model. Okay, Project Object Model. Tell me, in pom.xml file, okay, we have to configure the project dependencies. Project dependencies. Nothing but dependencies are nothing but what I told you here. Jars. Okay, jar files. Okay, we have to configure the project dependencies. Okay, tell me to configure the project dependencies, which tag we need to use? Dependency tag. To configure a dependency, okay, to configure a dependency. Dependency is nothing but what? Jar. Jar required for our project. For our project, we need some jars required. Okay, we need to have, or we need to have some jars, or we need to take the support from jars to develop our applications. So to configure a dependency, that dependency is nothing but jar files. To configure a dependency, we have to use which tag? Dependency tag. Which tag? Dependency tag. Okay, good. Tell me, under dependency tag, what are the three child tags that we are going to write? Group ID, artifact ID, version. Very good. Under dependency tag, we have to write three child tags. Okay. Tell me, what is the one child tag? Group ID. Group ID. Tell me what this group ID represents. What is group ID? A unique ID of an organization. A unique ID of an organization who provided the dependency, that jar or that project. A unique ID of an organization, that is called group ID. Next one, artifact ID. This is name of the jar file. Name of the jar file. Name of the jar file. Jar file is nothing but project. Name of the jar file is nothing but name of the project. Next one, version. Version of the project. Version of the jar file. Example. Example. Just now I've written. What tag I've written? Dependency. Tell me under dependency, what is the child tag I've written? Group ID. Group ID. What is group ID? org.spring framework. Group ID. Next, what we have written? Artifact ID. Artifact ID is what? Spring hyphen context. There are multiple jars provided by Spring Framework to develop the applications using Spring Framework. Version 6.2.2. Just for example to know this. So now did you guys understood about how to configure the dependency in the pom.xml? You will learn more about this later, but currently do you know this now? Right. And one important thing here. See, for example, assume that. Please try to understand now. I am creating one project. Guys, everybody try to understand what the point I'm saying now. Yeah. Answer is no. You should have separate dependency tags. Okay, come to the point. I'll tell you. See here, guys, what I'm trying to tell you now. See, this is your project. This is your project. You want to develop your project. Tell me to develop your project. You want to develop this project using which framework? Spring Framework. To develop your project using Spring Framework, then tell me, you need to get the support from the Spring Framework. So to get the support from the Spring Framework means common functionalities from the Spring Framework, then tell me we are going to add the Spring jar files as dependencies in the pom.xml file. This is my project. Okay, I want to develop this project using Spring Framework. Using Spring Framework. I want to develop this project using which framework now? Spring Framework. I want to develop this project using Spring Framework. To develop my project using Spring Framework, I need to get the common functionalities from where? Spring. How to get them to my project? By adding jars. Add jars. In which file? pom.xml. How can you add or configure any word? Configure jars in pom.xml. How do you configure these jars in pom.xml? By using dependency tag. That you know that. Okay, understand here. Try to understand. As I told you, just understand. As I told you, to develop a first Spring Framework application, okay, right? Tell me the support of how many jars are required for compiling and executing my first small application? 6 jar files required. How many jar files required? 6 jar files required. So tell me how many jars I need to configure in the pom.xml? Approximately 6 jar files I need to configure. But in Maven, the advantage is actually 6 jar files required. 6 jars. Let's say, for example, just for example, if you want, even I can show you them. Okay. Later, you will come to know more dependency hierarchy. You can see right side, not 6, many. Micrometer, commons, observe, right side one. Resolve dependencies are there, na? 1, 2, 3, 4, 5, 6 from Spring, plus 2 more extra. Micrometer, totally 8. Let us leave about these 2. These are related to JUnit. Leave it. What are the remaining 6? Spring, beans, context, core, expression, JCL. Totally how many jar files? 1, 2, 3, 4, 5, 6 jar files required. As I told you, 6 jars required for minimum to develop the first Spring application from Spring Framework side. But my question in the pom.xml file, how many you configured? In the pom.xml, I can remove the second one. It is not required. Just for your explanation, I've written. Tell me, how many dependency tags I've written here? 1 tag. Means 1 jar file. But see, how many jars are added to my project? 6 jar files. How it is possible? I written only one. Which one I written? Spring hyphen context I have written. This one I have written. This one I have written. But I'm getting all. How it is possible? So there is, I'll tell you, I'll show you. Okay, I will show you. Don't worry, I'll show you. How it is possible, I'll show you. Don't worry. See here, guys. Spring context I've written. It depends on Spring AOP. That again depends on beans and core. Now you tell me up to this part. Up to this part. Please try to understand now. Up to this part. How many jars are automatically downloaded? 3. Spring context including means 4. AOP, beans and core. Beans already downloaded now. Core is also downloaded now. So these are not downloaded again. Are you able to follow me now? Spring core already downloaded now. But it depends on what? So JCL is new one. Downloaded. Downloaded. 1, 2, 3, 4. This is what? 5. Next, what's the one more? Expression. 6. Are you able to follow me now? Right, very good. This is 7. This is 8. Totally tell me how many jar files are automatically downloaded just if I add Spring context? 8. So which means in Maven, I'll show you. In Maven, there is a concept called as
Excuse me, sir.
transitive dependencies. I'll tell you. First of all, I'll shrink them so that you can understand.
Excuse
Tell
me,
me.
sir.
Yeah.
Sir, on JUnit, we have to install JUnit separately
No,
or
no, 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 no. No need to install any. No, JUnit is a jar file only. No need to install any software for that.
okay, sir.
Yeah. Observe it, guys. Okay, that we'll discuss later. Coming to the point here.
Yes, sir.
Which jar file name I have given? Spring it depends on 1, 2, 3, 4, 5. Are you able to follow me? Which means, try to understand now. 1, 2, 3, 4, 5. Which means if I write this one in the pom.xml, if I write this dependency, it will automatically download these dependencies also, because these are transitive dependencies. What is transitive dependency? For example, a.jar required for my project, but a.jar depends on b.jar. This is my project. Tell me to my project which jar is required? A.jar. So I will add a.jar required to my project, but a.jar depends on b.jar. So what Maven will do? Will download a.jar and also b. Suppose if b.jar depends on c.jar, then you download c.jar. That's why how many jars are downloaded now? 6 plus 2, 8 jars downloaded. So A is the jar required to this project. But A jar depends on B jar. B jar depends on C jar. What Maven will do? Will download all. So we call this B and C are called transitive dependencies. What is that? Transitive dependencies. You know already, when A depends on B, B depends on C, then we say that A depends on C. Mathematics transitive formula, transitive dependency, the same concept here also. That's why totally all these jars are downloaded. Means in Maven, if you specify one jar as a dependency, it will only download that dependency or the transitive dependencies also. Transitive dependencies also. Tell me, how many I specified here? Only one. How many I have specified as a dependencies? Only one. Only one. But tell me what Maven has downloaded how many? Totally including this 8. 8. Are you getting my point now? That's also the other advantage of working with Maven. You don't need to specify 8 dependencies. If specify one dependency, but how many Maven downloaded? 8. Are you downloading or it is automatically downloaded? Automatically downloaded. It is there available in your system. I'll tell you, they are going to be stored at one location that is called repository. I'll tell you what is Maven repository next. But at least you got some idea today, hopefully. And tomorrow we are going to continue to have more discussion on this. Everybody get my point? Right. So here we'll stop. But tomorrow I'll give you more details about Maven. We'll try to conclude working with Maven. Maven archetypes and other things of Maven I will explain tomorrow. And so that from day of tomorrow, we can start working with the Spring and Maven together to develop the applications. Okay. Right. We'll continue tomorrow. Thanks. Online people, if you have any query, please ask me.